The Earth is over 4.5 billion years old. Its history is shaped by disaster after disaster.
Asteroid and comet collisions, flares from the sun,
mass extinctions, supernova explosions, cosmic ray bombardment.
You name it, we've experienced it.
Kind of a miracle we're here at all.
These violent events could be why Earth has life.
We tend to think of disaster as a bad thing, but out of chaos can come possibility. When we destroy something, we can also create something new.
Earth has walked the line between survival and destruction.
It's tipping that fine balance of luck between a good disaster and a bad disaster.
Could catastrophe and chaos be the essential ingredients for life? In 2021, scientists investigate something mysterious buried deep inside the Earth. It's a long-hidden clue to our violent past.
Deep down 1,800 miles below the surface of the Earth, our core is surrounded by fluid rock. But inside that, 600 miles high and thousands of miles across, are two denser regions, and they kind of cup the core of our planet like two hands.
One of them is, half the size of Australia, for crying out loud. So, I mean, they're big lumps down there.
There's no reason they should be there. It's a mystery to us.
To solve this mystery, scientists need to examine the rocks buried over 1,000 miles beneath the surface.
We don't really know what these two big rocks are made of sitting there on the core. However, we've been able to sample them. How in the world is that possible? Well, these blobs are actually feeding mantle plumes that are rising up through the mantle.
So volcanoes in Iceland and Samoa, for instance, will dredge up some of these lumps of rock from the mantle. It's a precious chance for us to sample some of that deep rock that we'd normally not get a chance to see.
These rocks are old, very old.
It turns out that the samples in the lava that we think came from these blobs of rock in the mantle are 4.5 billion years old. That is as old as the age of the Earth.
So they tell us something about how the internal structure of our planet was arranged in the earliest days of the formation of our planet. So getting samples from that time is very, very important.
The age of the rocks may be a clue to their origin. They date back to a time of monstrous cosmic mayhem.
Four and a half billion years ago, the solar system was still a pretty wild place. We're approaching the end of the formation of planets. Earth would still be growing.
Back then, you wouldn't necessarily recognize the Earth. In fact, you wouldn't recognize the Earth at all. For example, no moon. The Earth did not have a moon when it first formed.
The young Earth orbits the Sun with other infant planets. One of them is an object scientists call Theia. And it's on a collision course with our home.
The Theia collision would have been a spectacular event. It would have been one of the coolest things you could possibly witness in the origin of the solar system, certainly the biggest event in the history of the Earth.
The Theia event is something that completely reshaped the Earth. The planet that the Earth was before the Theia event is gone forever.
The impact melts rock and throws out over 1 billion tons of debris.
During this incredible collision, these two planets were literally broken apart and combined into one big planet. Huge chunks of Theia stayed together as the now molten Earth began to form anew.
Now we can kind of paint a picture of where these big lumps of rock might have come from. They're very old, They're in fact the same age as that large impact event. They could be pieces of Theia.
The giant slabs of Theia sink down into our planet and lie undiscovered for billions of years. Earth reforms from the ruins of both planets.
Now, you might think that a collision like this is just devastating. There's no upside at all. But there are some things that came out of this collision that may have led to the possibility of life.
When these two planets combine, parts of Theia's iron core merge with Earth's.
So that means that Earth collected a much bigger core than it might have possessed on its own. This is good news for us because the core is the source of the magnetic field that protects us.
Liquid metal flowing around in the outer core generates Earth's magnetic field, a protective shield from the sun.
The sun can actually output billions of tons of high-energy protons and electrons in a single burp. That eventually would have stripped away our atmosphere. If it weren't for that active core and that magnetic field, we would look like Mars, just sort of a bare and barren desert.
Thanks to Theia's extra iron, Earth's molten outer core is large. So it cools slowly, staying molten, and keeps on generating a strong magnetic shield.
Because of that collision, the extra iron, the extra heat, we've stayed active. We have a magnetic field. We are protected. And in fact, that's why we're here talking about it.
The catastrophic impact helped life in other ways.
The Theia event was absolutely huge. Not an impact like a 100-mile asteroid making a big crater in the desert, but a planet hitting a planet, causing a huge disk of debris spread out from the Earth, out of which formed the Moon.
After the collision, the Earth tilts on its side and spins incredibly fast. A day only lasts a few hours.
The Earth itself rotates slightly on its side, and if left to its own devices, would in fact experience unpredictable, chaotic wobbling. The fact that the Moon is there stabilizes the Earth, stabilizes our climate.
The Moon's gravitational pull on our oceans creates tides and slows down the Earth's spin, creating a world primed for life.
We actually owe quite a bit to the Moon and Theia, its progenitor, for making Earth a hospitable planet for life.
A giant collision 4.5 billion years ago sounds like a catastrophe, but it was probably the best thing to happen to the Earth. Theia, I would shake your hand because we have a lot to owe you.
We also owe the science of chance because we lucked out with a 1 in a million impact.
If the impact from Theia had been a little bit harder, the Earth may not have recovered as well as it did, and we may not be here to talk about it right now. If it had been a little bit less forceful, then the impact of it may not have made the changes that we think were needed for us to be here now.
We got lucky. Most planets don't get to survive a collision like that and get a bonus moon out of the deal.
Earth's huge collision with Theia was not our planet's first brush with danger. An earlier explosive event could have stopped the solar system from sparking into life and the Earth from forming. Supernovas are one of the universe's most destructive events, releasing in 1 second as much energy as our sun will in its entire lifetime. But rather than wipe us out, supernovas may have kick-started the solar system.
4.6 billion years ago, the solar system's not even really the solar system. It's the precursor of the solar system.